Quick show of hands, how many of you have worked with Hadoop MapReduce in any way? Okay, how many of you have worked with it using Python? All right, should be interesting. This won't be a deep dive. I won't get too geeky, but I do have some code posted out to a GitHub repo. You can go ahead and clone it, pull it down. I'll do a live example running through against some DC payment card transactions so that we can take a look at how they're spending their money, or rather where. My name's Danny Holloway. I'm the VP of Engineering at Human Geo. We work with Python whenever we can. Sometimes we work with Java when we have to. I already did, who am I? But I'm also going to talk about Hadoop, sort of a primer for anyone who hasn't had a chance to work with it yet, and then specifically on MapReduce, talk about the scenarios where it would come into play, why you would use it, how you can do it with Python, and then we'll actually look at some code and go over an example mapper, a reducer, the example I talked about earlier about DC's payment card transactions, and then sort of some next steps that aren't fully baked, but I can speak to them. So my interests, Python, data science, visualizations, geospatial applications, and development for the web. So Hadoop, more than just the yellow elephant, but it is named after a little stuffed yellow elephant. It's a storage and processing framework that handles the distribution, fault tolerance, and partitioning of jobs against large compute clusters of commodity hardware. So by taking all of that out of the hands of the developer, it allows you to write relatively simple processes for doing simple aggregations over massive data sets. So despite the fact that Google came out in the recent I.O. and said that they have moved on and no longer use MapReduce, I don't think it's dead yet. It's not the only way to process data. It is static analysis. It seems like people are moving towards a streaming analysis of data. It gives you a little bit more of real time, but it does come with its own challenges, so we won't go into that tonight. And it's not just for Java, so yay. So MapReduce is part of the Hadoop ecosystem, and it is what handles the distributed parallel processing. It was based on a Google research paper that was published back in 2004. If you haven't come across it, it's actually a pretty interesting paper just to read and get a good understanding of the fundamentals and what MapReduce was and sort of why it was created. So it's also a programming model. It's a pattern for manipulating data by mapping it and then reducing it. And there's a couple of steps in between that we'll go into in some detail. It's really good for big data, like the type of data that doesn't fit on one machine or even like a couple of small machines. It's really good when you've got structured, normalized, potentially even just machine-generated data. So things like logs are great for analysis with a MapReduce type job. It is batch analysis, so it's not the kind of thing that you're going to be able to like run all the time and get an answer to. But if freshness isn't the most important thing to you, and you can say, like, data that's 1 hour old, or the question that I asked an hour ago, the answer is still relevant and important to my users. It could be like a suggestion that you're making based on all the activity that you're mining from your server logs, based on some background processing, where you don't necessarily have to have up-to-the-minute answers. And it's good for simple aggregate computations, so things like averages, counts. You can get into more complex reductions, but you start to kind of constrain yourself if you're trying to do anything more serious than that with MapReduce. It's really bad when you just have data locally. It's a bunch of unnecessary burden and sort of cruft that you don't necessarily need. It's not very good for unstructured data. So if you're not working with records that are in a repeatable, quickly parsable pattern, this isn't really going to be a great way to analyze that information. It's also not good for real-time analysis or data with high cardinality. So when we go into the example of the mapper, you'll understand why. So why do I use it? MapReduce comes into play when you've either got too much data to store on one machine, or the question you're asking takes too long to answer using one machine. So, if a job could be run on my laptop, but it takes 10 hours to finish, and by 10 hours down the road, the answer has changed significantly and it's no longer relevant. But I need to recruit a larger workforce of machines as part of my cluster to get the job done in a time that answers my actual functional need. So when your real-time answer is not critical, it's a proven technology. It's been around. It's based on a paper in 2004. There's books. There's entire markets created. So companies like Cloudera have created their own package and distribution of Hadoop that makes the administration, configuration, and setup much simpler. And they also offer support. So it's not some fly-by-night thing where the spec's changing day by day. It's well documented and it's an active community. I'm not saying that you're necessarily out there to avoid, but maybe you don't want to use the factory method observer singleton pattern every time you want to write a simple MapReduce to key value pairs. So here, Hadoop streaming comes into play. And this is part of the Hadoop ecosystem. It's a packet, or it's a jar, that allows you to use executables as your mapper and your reducer. And because we can make our Python scripts executable, we can use those as our mappers and our reducers, or one or the other. So really, it's kind of unshackling you from the Java ecosystem, but still allowing you to harness the power of Hadoop MapReduce.
Does that substantially impact performance?
I haven't done any benchmarking, but I have to assume that it would. Python isn't the fastest language in the world, but that's an interesting question. I'd have to run some benchmarks to check. So here's an example mapper. And mapper, the way I think of it is we're mapping our records to keys and values. So essentially what we're going to do is go through, in this case it's a large text file, a CSV, and break out what the key is for each record and what the value is. And I've made it a little bit generic so that we could map and reduce or make different keys and values in different positions. So they're just command line arguments for the key and the value. And essentially I used the CSV reader because there were some quotations around the CSVs, and some of my columns actually had commas in line. So I get some added benefit of character escaping and CSV processing by just importing the CSV reader. But essentially, we're opening a file, and in this case, it happens to be sys.standardin. So I could pipe an echo command into this to test out my mapper, and I'll show an example of that. But essentially, for each row in the file, or each line in the file, I'm just going to go ahead and grab at the K index and the V index, strip it off just to make it nice, and then I'm going to go ahead and print that out with a tab delimiter. And that's it. That's the mapper. The reducer is typically where your application-specific or domain-specific code will be. We could have made more complex mappers. If we were actually working across a number of different data formats and we wanted to sort of merge them together, we may need to have conditional mapping. But in this case, we're just working on one text file. And so the reducer essentially works on the principle that the output coming from my mapper is going to be keys and values, but they're going to be sorted. And that's critical to understanding how this works. So you can see we've got a for loop where the bulk of our code's running. And outside of that, we're looking at two variables, the current vendor and the total amount that we're going to use to sort of track our progress as we work through the mapped output. So again, we're reading from standard in. So essentially, the Hadoop streaming jar is handling the passing of the data from our mapper executable into the sort, and then back into the reducer. And as we go through, we're going to go ahead and split on the tab that we used to separate our keys and values, assign those variables to vendor name and transaction amount, and then we're going to do a quick cast to make that transaction amount afloat. Everything you read in is a string. We've got a broad general try except, which I usually try to avoid, but in this case, I'll just fail silently and let it go away. The transaction amount happens to not be afloat. And that allowed me to get past having to either strip away the row headings on my CSV. It just skips that record. And basically do a quick check and say if the vendor's changed, then, if the current vendor hasn't been set and it's initialized to none, we're going to go ahead and assign that to vendor name. And then, as soon as this comes back, I'll tell you about the rest.
This part was written in Java.
Yeah. If our vendor name matches our current vendor, I'm going to go ahead and take the amount for that line and add it to my current running total. If it doesn't, I'm going to go ahead and print out the previous key and value. So essentially that's the last vendor and all the totals that we've added up to this point. Remember, it's in sorted order. So I've done all the computation for a vendor. I'm going to go ahead and output that. And then I'm going to reset my total amount to the transaction amount of the first map value and set the new vendor. And essentially we iterate that until we've gotten through the entire contents of the file. And then we've got one last print statement at the bottom to get the last vendor. Don't forget that, or you'll miss like Zappos.com or whatever it was. So now, how does DC spend its money? So data.dc.gov has a number of different data sets that they make available. Some of it's GIS data, some of it's CSVs, text files. I thought the payment card transaction file was actually pretty interesting. This is actually, I guess, the purchase cards that they give their government employees to go out and make official purchases for work-related things. But as you start digging into the data, you may wonder if that's really the case. I don't know. I'm not really insinuating anything here, but you should take a look. We've got a bash script, and essentially that's what this screen capture down on the bottom is. That's just kicking off the job. And so we've got our Hadoop executable. If you're working on OS X like I am, you can do a quick brew install Hadoop. It'll grab the latest release and install it very nicely, and you're off and running. You then specify that you're going to be running a jar, and you give it a path to the Hadoop streaming jar. And then we're specifying some arguments for our mapper and our reducer. So typically, if you were going to run this on a cluster of nodes, you'd be running over HDFS. And these files would be on HDFS. And really, if you're using MapReduce, you probably want to be on HDFS. Otherwise, there's not much advantage to doing it. In this case, I'm working off the local file system, just to get through this example. So I tell it that my mapper, or that I need to package up the mapper.py and the reducer.py, and that would all go into a jar that gets kicked off and run by the task manager on all the nodes where my data is residing. So essentially we're moving code to where the data is, as opposed to bringing all the data together to run code against it. And so I've specified a file, and then I've actually given it the command to do the mapping and the reducing. And so if you remember back at the mapper example, we specified the key and the value as command line arguments. So this is saying in the third position and the second position, that's where my key and my value is. The reducer, we don't have any arguments. We're just going to simply call it reducer.py. And then for input, we've got the CSV that we downloaded from data.dc.gov. And there's a bash script that will go out and actually like download it, unzip it, put it in the right directory if you clone the Git repo. And then all of our output is going to go into the output directory. One thing that's kind of weird is that it doesn't like that output directory to be there when you start. I don't know. I think they could either just prompt you or like blow it away or something, but you should delete it first. Otherwise, it'll complain and you'll wonder what you did wrong, but really you just didn't delete the output directory. So with that, I'm going to hop over and actually run it. Actually, let me show you the script real quick. So our get data script is, oh, you can't see it. Mirroring. Sorry. And you can't read that. Okay, so it's a quick curl command to go out and grab the zip, unzip it, and clean up the zip when we're done. And essentially we're just going to write that into our input directory. Here's our management job where we delete the output directory, set a variable for where our Hadoop home is. So if you were to grab this, the only thing you'd need to do to configure it for your local environment is run get data and then make sure that the Hadoop home is correctly set for your environment. And then we'll kick off the job. So you can see some verbose output. You can't see that at all.
No, that's good.
Essentially, what you're looking for is that completed successfully. You may not get it on the first try, but I think if you clone the repo, run the commands based on the README, it'll work. You get some stats on the number of bytes read, the number of, like, how much of the map and the reduce completed, and any errors that were encountered along the way. And then you should see that your output directory is where everything was written. So if we do ls of output, we'll see an underscore success, more affirmations that we haven't screwed anything up. I think it's failure or fail, I forget what you get. But essentially, if we look at the part, you can see that we've got our vendor on the left and the dollar amount on the right. So we did about 30,000 records. I didn't put a time on it. I know there's a time somewhere in here, but it was relatively quick. But it may have been faster to process this locally without going to MapReduce. If we were working with a massive data set and we needed to enlist an army of compute resources, that's where the MapReduce would come into play. There's a library that I can't recommend highly enough, Mr. Job, which is great. It was developed by Yelp. And essentially it allows you to do this local development, but then by providing AWS keys, it will handle everything from moving your data up into S3 or interacting with your data in S3, and then spinning up a complete EMR, Elastic MapReduce job for you. So it's a great way to get up and running, and then for a relatively low cost, depending on how much data you have and how complex your map and reduce is, actually run it on instances inside of AWS.
What was the name again?
Mr. Job. No capitalization, spaces, or underscores or anything. So just kind of a cool name for a project, too. So one of the things that I did first was sort it by dollar amount. Because obviously we want to know where they spent the most money. No one really cares about where they spent the least. I don't. Standard office supply, like nearly $4.5 million. And so this is a running total to date for the calendar year. And
Laser art ink.
yeah, there's some really weird stuff in here.
A lot of Amazon purchases.
Jimmy Muscatellos.
Yeah. Just saw that.
This one blew me away. They've spent like nearly $50,000 at SurveyMonkey. I don't even know how you do that. So, you know, once you pull this down, played with it, go ahead and take a look at the results. I don't know, maybe we'll find some inappropriate spending. If not, it's humorous. So that's all I've got for the presentation. I'll open it up to questions. Let me just go back to my slides.
Why don't I give money to help/help SurveyMonkey/help?
There's a lot of interesting stuff in there. We're hiring at Human Geo, so if you guys are looking for work and you like working with Python and digging into data and finding interesting stuff, you can find us in the back of the room. You can find me on Twitter. I don't really do it very much, but that's where I'm at Holloway Danny. Email danny@thehumangeo.com, and I didn't post a URL to the GitHub repo, but it is on the discussion for the meetup. So
yeah,
you should be able to find it there. Any questions? Yeah.
First, wait.
The reduce function assumes that the data is in sorted format that it gets in. Did the mapper sort it, or is the CSV in some sorted?
No. So let me show you something kind of cool. Gotta go back to here. So the Hadoop process actually handles the sort. It also does partitioning. So what it does if you're working with lots of data is it will chunk it out and say, like, this job or this chunk of data is going to be managed by this node in this cluster, and this chunk of data is going to be managed by this node, and we're going to sort all of it locally and then sort it again when we bring it back together and merge our results. So what you can do, and I meant to show this, I just got lost, is you can actually work with streams, much like Hadoop streaming does, just if you're working in Bash or a Unix environment, by catting the file, piping it to your mapper, piping that to sort, and then piping that to reducer, and you'll get the same output. So it's really great for rapidly prototyping and proving out that your MapReduce fundamentals work without having to like worry about whether or not you've correctly configured your HDFS or whether you've got Hadoop installed. So I think it's really neat that you can just kind of pipe all these pieces together and work on the fundamental principles of MapReduce without actually relying on Hadoop and MapReduce. But yeah, just there's an inline sort when you run it this way, but Hadoop handles it when you go through the Hadoop process. That's a great question.
I guess a question about reducer.
Sure.
So from how the code looked like, you couldn't run something like median.
Yeah, so median would be more complex. So I kind of talked about simple aggregations, and
Right.
really you'd have to come up with a mathematical model to compute something like a median or an average or a rolling or any sort of statistical model, and then you've got to worry about memory management. But the way that MapReduce works is by keeping things very stateless, and that's how you can operate in the distributed model
Right.
without having to handle any of the distribution headaches.
Cool. Thanks.
Anyone else?
Going once, going twice. All right.